Okay, first thing we're going to do is we're going to start drawing our shape in. So a particle is acted upon by two forces, one of magnitude 5 newtons acting east. So there we go, there he is going east. The other with a magnitude of 12 newtons is acting in the direction of north, 60 degrees west. So let's add in another shape. That means the resultant force is going to be acting. Now, we're assuming that our resultant force is going to have an acceleration of 0. So we're going to do another one. I'll change the colour of this one. There we go. It'll be acting in that direction. So now I can start to write some stuff on this thing. Okay, so let's say this one here is 5 newtons. Ah! What just happened? Undo. Why? Oh, there. Five newtons. Okay, this one over here is going to be 12 newtons, and north in here will be 60 degrees. And we can call this one F1, this one can be F2, and this one can be F3. Okay, so I'm going to split it up into each parts of the vectors. So force 1 can be expressed as 5I, because it's only acting in this direction. Now, force 2, the I component is going this way. If I draw it in my vectors, that's one, that's the other one. So this one here is opposite, and this one here is the adjacent side. So if I'm looking at the way it's acting, it's going that way, meaning it's going to be negative 12. It's sine because this is opposite, and it's 60 degrees because that's our ratio. The I direction plus because it's going up, 12 cos because it's adjacent, 60 j. Okay, so now we can simplify this further. Sine of 60 degrees is root 3 on 2 using our hand trick, which can simplify to negative 6 root 3i. And 12 cos of 60 is a half, meaning that this will be plus 6j. Okay, now we can find out our third force is going to be equal to some I component. We'll just call it F for the moment, or F3, plus F3j. Now, when I'm looking at this picture, I can clearly see that it's going to be negative for the j component and positive for the I component, but it won't matter here, it'll work out in the end. So, next thing I'm going to do is I'm going to assume that the particle is at rest. Assume the particle is at rest, and then I'm going to let the force equal the mass by the acceleration, where acceleration is at 0, meaning that our force is equal to 0. So that means that for the I components, 0 is equal to, now I'm going to look for my I components, this one, and then we've got this one, and then this one. 5i minus 6 root 3i plus F3i. Yep. Okay, so now the next thing that I'm going to do is move F3 to the, well, this one to the other side, and then that's going to change all these symbols, because technically when this comes over, it becomes negative, and then I'll divide this side by negative 1. So that means that I'm going to have 6 root 3 plus 5, minus 5i. Okay, now we're going to do the same thing with the j component. So J, I don't know how to edit the videos, so whatever you say, the kids are going to hear.
Don't add the bacon, is it right in there, or?
No.
Or buy some more?
Yes.
Yeah.
You could just cook it without the bacon. Okay, so J component is going to be 0 equals now we're going to group together our J components. Now here there's no J component, it's 0, so we just ignore it. We've got one there and we've got one here. So that means 0 is going to be equal to 6J plus F3J. So F3J is equal to negative 6J. Okay, so now ideally I'd like to keep going down the page so that it's neat, but, you know, I don't have that option here. Okay, so now next thing we're going to do is we are going to find the magnitude because it's asking us to calculate the magnitude. So if I was going to state what this thing is, F3, or the resultant force, is currently given by 6 root 3 minus 5 I minus 6J. Okay, so let's calculate the magnitude. So the magnitude of F3. Now, this notation is important because it means that we are absoluting it. So the square root of negative 6 squared, and it's really taking the absolute here. We just don't normally write that because we're lazy. But here you'll see in a second why that's important. Okay, so we know the square root of 6 squared is going to be 36 plus. Now this part over here, I'm just going to do as a little separate calculation. So 6 root 3 minus 5 times 6 root 3 minus 5. And I'm absoluting that. Okay, so that's going to become 6 times 6 is 36. Root 3 times root 3 will be times 3. Then I've got minus 30 root 3 minus 30 root 3 plus 25. This, when I expand it all out, 36 times 3 is going to be 3 times that is 8, 108. So 108 minus 60 root 3 plus 25. So plus 25 will give me 133. So this will turn into 133 minus 60 root 3. And when I absolute it, it's going to turn that into a positive. Now, I do think that it's supposed to be absoluted here. So this should have been a positive and this should have been a positive, and that could have followed through. So just be aware that that is what's happening. That's why it becomes a plus in here. Okay, so now I've got 133 plus 60 root 3. Whee. Okay, and that, when I add these two together, is going to become the square root of 9, or 169, plus 60 root 3. So it's just a different way of interpreting it to the way that they've done it. Same answer, doesn't matter what you do.